Hi guys, in this lesson we are going to discuss about properties of real numbers. So the objective of this lesson to identify and use the properties of real numbers. Let's see these properties. So first thing first, let's see the vocabulary that we have. Equivalent expression, deductive reasoning, counterexample. So the meaning of equivalent expression is if they have the same value for all values of the variable. For example, 15 minus 1 is equals to 16 minus, let's say, 2. So this is equals to 14 and this is equals to 14. So this numerical expression and this numerical expression, they have the same value, so these are equivalent expression. So that's the meaning of equivalent expression. Let's see where do we need equivalent expression in. So in algebra, we have addition property and multiplication property. So the first one is commutative property of addition and multiplication, which means you can change the order for them. Once you change the order, you still get the same value. I mean, if you have 3 times 2, it will give you the same thing if you say 2 times 3. This will be 6. This is also 6. So these are equivalent. So changing the order in addition and multiplication is okay. So this is the first property. Next we have, keep in mind that you cannot change the order in division and subtraction. Like for example, you can say 3, or let me say 6 minus 3. 6 minus 3, it is not equals to 3 minus 6, because this will give you, according to the sign rule that you learned in the grade 7, it will give you 3. While here, you will get negative 3. But 3, it's not equals to negative 3. So, the order in subtraction and division aren't same. You need to focus on that. So, the commutative property, which means changing the order of the adding, does not change the sum, which keep the same value, which keep them equivalent expression. So the first property is addition, commutative property of addition and multiplication. Next we have associative property of addition and multiplication, which means grouping the values. I mean, if you have numbers like this, 23 for example plus 9 plus 4, and the parenthesis between 23 and 9, while here the parenthesis between 9 and 4, so these two values will be exactly the same. Why? According to associative property of addition and multiplication. The next property that we have, identity property of addition and multiplication. We know once we add 0 to any number, we will get the same number. 3 plus 0, it's 3. Nothing changed. This is the identity of addition. So, identity property of addition, which means adding 0 to any number will be same. For multiplication, 1. Once you multiply 1 by anything, you will get it itself. 3 times 1, it will be 3. Nothing changed. So in multiplication, once we multiply 1, we will get same thing. In addition, once we add 0, we will get same thing. That is identity property of addition. Now, we have also zero property of multiplication. What is zero property of multiplication? Once you multiply anything by 0, any number by 0, you will get 0. So zero property of multiplication from its names directly will give you result 0. Finally, we have multiplication property of negative 1, multiplication property of negative 1, which means once you multiply by negative 1, you will get negative of the number that you have. Let's use this in our exercises. So here we have what property is isolated by each statement. The first one, 42 times 0. The result is 0. So that is 0 property of multiplication. Just say that is 0 property of multiplication. Next, you have y plus 2.5 plus 28. While here, they grouped this part and they changed the grouping between them. So changing the grouping, which means the associative property of addition, because between them all addition. Now, the last one, 10x plus 0, it's 10x. So that is identity property of addition. So that is an identity property of addition. Let's see here what we have to say. We just need to classify them. What did we do and why these are equals? Just say by saying the property that we have. So 4x times 1 will give me 4x. That's the identity of multiplication. You need just to say that's identity property of multiplication. I will write the word prop and then dot to make the short form of a property of multiplication. The next one that we have here x plus the square root of y plus z equals to x plus z plus the square root of y. So it is just changing the grouping and it's changing the order, if you notice, and group them. Here it's not changing only grouping like this by keeping them the same order, while here you have changed the order for them and group them. So here the most important thing that you have to say, that is the commutative property of multiplication. So that is the commutative property of multiplication. Of addition. Now we have here more exercises. We can just say them. That's commutative property of addition. That's that's zero property of multiplication. That's identity property of multiplication. That's commutative property of multiplication. That's the identity property of addition, while here we have, for this part, we have -1 property of multiplication, and that's it. Now let's move to the next part. Here we have using a property for mental math calculation. So here we need to write the expression that we have to find the total ticket. So a movie ticket cost is this one. Then a drink cost is this one, and popcorn costs 1.25. What is the total cost? So the total cost is the total cost for a ticket, a drink, and popcorn. Use mental math. So first thing first, you know the total cost. You are going to add them all to get the total, how much you should pay. So they need here from you, they need you to use the properties. But basically, it's really simple. You can just add them by the way that you like. So plus 1.25. So what did they want you do, you can just use associative property to group just only the first two numbers, then add the last number. So you can just add these two numbers by adding them like this. I just would like to remind you how to just add them basically. I'm not going to add everything, but I will remind you in some of them. So the addition here will be 5, that will be 11. Then here we have 7 and 2, it will be 10. So drop this one, so that will be 10. So here it will be 10 plus 1.25. You can just add them just regularly to see the result, which will be 10 plus 1.25. So that is 10. That is 2, 3, 4. And then here we have 11. So 11.4. So you can say that here you used associative property of addition. You can group 2.4 and 1.25. Don't surprise if you see it in the book, they add these and then they add 7.75, which will give you exactly the same result, 11.4. Now, let's move to the next, the exercise related to this one. So, a can holds a 3 tennis ball. So, a can, let's imagine, can holds 3 tennis ball. So, 3 tennis ball. Then we have now a box hold 4 cans. So the box hold 4 cans. Now a case holds 6 boxes. Now how many tennis balls are in 10 cases? So you know that in one case there is 6 in one case. This is for one case. There is 6 boxes. In each box there is 4 cans. So just multiply them. In each cans there is 3 tennis balls. So 3. So that will give you, you can just use just grouping by grouping some of them. You can just, it's up to you if you want to multiply this to get a 12, or if you want to multiply 6 times 4 first, which is 24, then saying 24 times 3 to get 72. Then this is not the result. This is only for only one case. How can I find it for 10 cases? Just multiply 72 times 10, which will give you 720 tennis balls. So this is the idea. I would like to repeat just what I just said again. So first thing first, I will find it for only one case. So one case can hold 6 boxes. So that's what I did, 6 boxes. In each box 4 cans. In each box 4 cans. In each can 3 tennis balls. So just multiply them all together to get in each case 72. Now for 10 cases, 72 times 10, then you will get 720. Now here basically it's just easy to say here, simplify each expression. You can just add them regularly by the way that you like. You can group these two first, then add, or you can group these two to add. So here 21 plus 6, which is 27. 27 plus 9, which is equals to, by using associative property of addition. Here I'm grouping, which means I'm using associative property of addition. So 27 plus 9, which is will give you 36. That's the idea from this part. The rest exactly the same idea. Now let's move to writing equivalent expression. We want to simplify each expression from what we have by justifying each step by step. So 5 times 3n. Here, since here between the multiplication, we can just change the order for them. So we can just say immediately that's equals to, by changing the group, 5 times this is parentheses. By using associative property of multiplication, we can group these together and leave the n. By using associative property of multiplication, then we can multiply these since these two numbers. So that's 15n. Now that's it. Done. Now let's move to the next question. 4 plus 7b. Now we cannot add these. I would like to remind you, you cannot add unlike terms. Please keep in mind that unlike terms you cannot add them. So 7 and let's say 3x, these are not like terms. You cannot say that this is, for example, 10x or 10 or 10. That's wrong. Keep in mind, these are not like terms. But if you have 7x plus 3x, in this case, you can say this is 10x. So, like terms means the same variable, the same power of the variable. So keep this in mind. Same variable, same power of the variable to have like terms. So here you cannot add them immediately. You must change the order of these terms. So first thing first, let's say 4 plus 7b plus 8, and we are going to change the order for these by using associative property. Then we can change the order for them. 4 plus 7b, we can write 8 plus 7b, which is by using commutative property. Then by using associative property again, we can say 4 plus 8 plus 7b. Now we can add these since these are like terms, which means these are numbers. So that is a 12 plus 7b. Can I simplify it more? No, this is the simplest form. So you can say here, what did we use? Here we used again associative property of addition. So definitely in the coming lessons, we won't do all these processes to get the answer. We can immediately just with learning more, or once we just make more exercises, we will feel that this is very easy to do and we don't need all these processes, unless if I say by justifying your answer. In this case, you need to use all these processes. So you can directly say add 4 with 8 to say that is 12 plus 7b, or if you change the order for them because of commutative property, you can say that is 7b plus 12, which is also correct. Now let's work on this one. This is already in simplest form. We cannot just, this is y, sorry, that's a y, but it looks v, that's a y. So we can simplify this. So 6x we can do, then we can say y, and then we can write times 1 over y by using what? By using identity property of multiplication, isn't it? Then we can say by changing the order by using associative property, we can say 6x times y times 1 over y. So that's a value with its reciprocal. You can simplify these together to get 1. So that is again 6x times 1 by using identity property again, identity property of multiplication to get 6x. So that's the simplest form. So in the coming again days, you will just say, okay, miss, I can just cancel these together to say this is 6x immediately. Now, let's do these exercises without justifying the answer. What I was telling you is just a basic because I want you to know the idea and how I'm using these properties. Without using, with directly using them, just easy without justifying each step, I can just directly multiply these together to say 2.1 times 4.5, which is equals to 9.45 x. I'm done. I just group these two together and multiply them. Keep in mind that 2.1 plus 4.5 x, that is, you cannot simplify it. You cannot simplify this one because this is unlike term. While if this is stuck, which means it means multiplication, which means you can use them. You can multiply them together by using associative property of multiplication. So 6 and 3, these are the like terms. So 6 and 3, it's 9 plus 4h. Here, we can simplify m, a number on the top and a number on the bottom, and I can simplify 8 with a 12 by 4. This will be 2, this will be 3. Then we get to get 2 over, what is the remaining from the denominator? 2 over 3n. That's it. This is the simplest form. That's how we simplify them easily. I would like just to make sure that you understand the idea because I don't know about you before. So, you know that 12 over 8, you can just say, I can divide this one by common between them. Greatest common factor, which is the greatest common factor between them by 4. So once you divide this by 4, you will get 3. Once you divide this one by 4, you will get 2. That's what I'm doing. Exactly same thing if I tell you 3 over 3, that is 1. So same thing even if we have letters like this, m and m, which means it's a variable. But these all together will be like algebraic expression. Let's simplify more to make sure justify each step. Since they said justify each step, it means we need to use our properties of real numbers and we need to say what did we do in each step. So let's solve some exercises. I'm going to solve the first one. So here, first thing first, 556 a, I can just say b and then times 1 over b. Hopefully this thing makes sense for you by using identity property of multiplication. Then we can say 56, I need to have b with this b together. So I will keep a, and by using associative property, I will collect b times 1 over b. By simplifying these together, you will get this one. So that is will be equals to 56a times 1, which is equals to, by using identity property of multiplication, to get 56a. Let me justify each step that I did. I just here factor them. Here I just used associative property of multiplication. I'm not writing everything, just short. Then here identity multiplication again. And then I got the result. This is the simplest form. Let's make more example. I'm going to make this one because this is direct example. So that will be by using directly associative property of, so that is equals to 18x associative property of multiplication. If we solve this one, we can just say, first thing first, we need to change the order. Let me solve it here, and it will be the last question in this part. So first thing first, I'm going to change the order. I will write 0, 5x plus 4 plus 5. Then here by commutative property, that's what I did. Then next, I can use by associative property 4 plus 5. By using associative of addition, then that's equals to 105x plus 9. That's it. So, and like that, you can just done. So that's simplifying. Now let's move to this vocabulary. Here in this part, we have deductive reasoning and counterexample. So deductive reasoning, it's kind of a proof your, or just justify your logical steps that you do, which is exactly same thing that I did here. When I move from a step to another step, I'm writing what did I do by using properties. So what I call this one, I'm calling it deductive reasoning, which means I'm justifying each step by using deductive reasoning. Now, sometime you have wrong result. You know that this is wrong. You cannot, I'm giving you, for example, let me give you example. I'm telling you that A minus B equals to B minus A. You will tell me, Miss, that's wrong. That's not correct. You told us the commutative property, it cannot be with subtraction. It must be with something with addition only, and addition and multiplication. So in this case, you need to prove your speech. You have to say why. You will give something, we call it counterexample. What do you mean by counterexample? Say, let A be, for example, 7. Let B equals to, for example, 2. Now apply it here to say Okay, 7 minus 2, it's equals to 5. While 2 minus 7, it's equals to negative 5. And 5, it's not equals to negative 5. That's the counter example, which means I'm giving you a statement, and you know this statement is wrong, and then you need to prove why this is wrong. Just give counter example, and then you will get the result correct. And that's counter example mean. What counter example mean? Now let's see what we have here. Is the statement true or false? Give counter example if it's false. If it's correct, as I said, you must use a property to prove that. So let's see the first one. A times B equals to B plus A. Definitely you know that this is false. These are different operations. How is this possible? This is not possible. So just give example. 5 times 3, it is not the same 3 plus 5. This will be 15, while this is equals to 8. So that's not equal each other. That means this statement is wrong. That's counter example. Now, A plus B equals C equals B plus A plus C. That makes sense. That's correct. But I cannot say directly that's correct. I must use properties to reach this result. I'll start from one side. The first side, for example, I will start from this side and then I will try to reach to the other side by using logical step, which is logical steps, which means deductive reasoning. Right, what will I gonna do? First thing first, I'm going to use commutative property of addition to exchange these two terms. So once I exchange these two terms, which will be B plus A, right? Then I'm going to use associative property of addition to change the parenthesis place, and then I got the result. So that's really simple. Now let's move to practice this part. Is each statement in part A and B true or false? If it's false, give counterexample. If it's true, use the properties of real numbers to show the expression are equivalent. So, for the first one, is this correct? Yes, it is correct. Because this is correct, I have to justify my answer step by step. So, I'll start as I said, step by step. K, I'll start from this side this time. Plus 0 times J. I want to reach to J times K. Right, let me do it step by step. Step by step, that is what? K plus 0 will give me K. Why? According to identity property, using identity property of addition. It will give me this result. Then just drop your dot, J, and you reach the result. This one. For all real numbers, m times n plus 1, it's equals to mn plus 1. That's wrong. Let's give example, counter example. So m, if we choose m equals to 2, for example. If we choose n equals to 4. Once we substitute 2 times 4 plus 1, this is not equal to 2 times 4 plus 1. This will give you 5 times 2, which is 10. While here you have it 8 plus 1, which is 9. So 9 it's not equals to 10, and that's your counter example. Now, is the statement in part A of a problem 4 false for every pair of real numbers A and B? So, is this always false? We can say no, it's not always false. In some specific numbers, we can get it right in some specific numbers. Let's see these specific numbers. So if we have both of them, A and B both zeros, if A and B zero, like 0 times 0, it's equals 0 plus 0. So it's not always wrong, but it is most the time wrong. Also, if we have 2 times 2 will give me 4. Also, 2 plus 2 will give me 4. So if I have 2 or 0, it will be correct answer. So that's the answer for C. So C, the answer is no. It will be true if A and B equals to 0 or 2. That's the answer. Now here more exercises which is related to. I will leave these exercises for you. Practice them. If you have a question you can ask. Good luck, girls, and this is the end of the lesson, and bye.